Hello and welcome back to Calculus 1. We are starting chapter 3. Entire chapter 3 and chapter 4 will be on derivatives. So today we're going to take a look at the idea of the derivative. But before that, let's take a look at change first. So if I have a straight linear line, say L, and I pick 2 points, point A and point B, I can get the values, say XA, YA, and XB, YB. Now, there is a change from A and B because A and B are not the same points in space. The way we look at this is we had to move forward to the right and up in order to get from A to B. Now in algebra, we can calculate the slope, which will show the change. So slope M would be YB minus YA divided by XB minus XA. Now in mathematics, we like symbols. So delta Y is known as change in Y, and that one is YB minus YA. Delta X is known as change in X, and that one is given as XB minus XA. So now, looking back at your good old algebra slope, YB minus YA divided by XB minus XA can be simply denoted as delta Y over delta X. So this is the formula for slope, and this slope formula measures the change. So let's say price of the car after X years. So price, let's say price Y of the car after X years. And we can just put a depreciation line over here, let's say from 30,000, and let's say you have, say 30 years and the car is completely worthless. We can come up with a slope because this 30K is going to be year 0 and 30,000, and this point here would be 30 years and 0 value. So I can now use my slope formula, change in Y over change in X, to see that 30,000 divided by 30, and I'm going to put negative because the value is diminishing. When I cancel, I get negative 1,000 over 1. Now, I know that you would put negative 1,000, but I really want this over 1 because slope gives us the rate of change in time. So, I interpret this slope as car loses $1,000 in value per year. That's the way we understand the slope. Car loses $1,000 in value each year. So 30 years later, in our case over here, it has zero value because every year you deduct 1,000. Now, we all know the story. When you buy a new car, you drive it off the lot and it's immediately depreciated 70%. All that stands. But, for the sake of the problem, I could have used anything else. So as long as you understand that change in X and change in Y are happening at the same time. And now we're going to switch to calculus. I am going to bring a motion to the game. Here's some function f of x. And I'm going to put 2 points, point P and point Q. Now, point P is going to be a fixed point. Fixed point at A, f of A. So point P is a fixed point. Point Q moves towards point P. So point Q will have xy coordinates because that's the point which will take on all of the x and corresponding y values one by one until it reaches or passes P. So now, if I connect these two with a straight line segment, I can calculate the slope of this line. So slope, and we call this slope of a secant line. In Greek, secant means to cut. So you see that this blue line cuts off a part of a function. And we can find this slope by writing yq minus yp divided by xq minus xp, simply change in y divided by change in x. No matter where point Q goes, you will be able to stretch this blue line from Q to Q star, Q 2 stars, and so on. As Q approaches P, you always have the blue lines established. And you see that they're corresponding, right, their x values are moving towards A. And we can calculate all of these slopes. We can calculate all of these slopes except when P collides with Q. Now, there's going to be a line with a slope there as well, this red one. And then when the Q passes by to the other side, we will continue with blue lines again, covered with this. So using algebra, we can calculate all of the slopes of blue lines, and we cannot compute the slope of the red line. Slope of the red line has an issue. What's the issue for calculating slope of the red line? Exactly, 1 point. So what happens when the P is the same as Q? What happens with our calculation in blue? What is happening with our calculation for the slope formula written in blue as P and Q occupy the same spot in space? Divide by 0. Excellent. So the x coordinate of point P and x coordinate of point Q become the same point. Their coordinates in x become the same, and you get delta y to be 0 and delta x to be 0 because the points are in the same spot. So algebra would fail to compute. But we know that there is a line there. So is there a method to actually compute the slope of the red line? If you look closely, what can we use to calculate that slope? What concept? Well, the line will be called tangent. That's the name of the line. The question is, how do we compute it first? Which one? Which concept to calculate? We can't use the slope. We did not have, we did have the concept before, but we did not have it in this slide. So, can we compute all of the blue lines?
Yes.
Can we compute the red line? No. So which mathematical concept doesn't care about computing at the point but cares about computing in all other points? The limit, exactly. We said that way too many times last time. Let all points be defined, right, except maybe the point you're looking at. So the entire last week we talked about limit, and anytime we use the chart or any method, we never computed at the point, we always computed around the point. So it seems that in order for us to calculate this special red line, which we'll call tangent, so this makes it into a tangent line, we will take the limit as x goes to a, right? Limit as x goes to a of m secant, which is limit x goes to a of delta y divided by delta x. So now I would like to develop that formula. Limit x goes to a, and now for y's I need to put f of x minus f of a divided by x minus a. So this is a formula, and this one would calculate the red line, slope of the red line. Now this is not particularly nice calculation, so we can do a little bit better if we define this x minus a as age. So now, to derive this, if I subtract a on both sides in the limit, I get that m tangent is equal to the limit x minus a goes to 0, and the x value would be a plus age. So now I have f, and instead of x I'll put my a plus age minus f of a divided by age. Which gives us the formula for m tangent as limit age goes to 0, f of a plus age minus f of a divided by age. Does anyone recognize the formula?
Yes, I think I do.
Difference quotient. Good. It's a difference quotient formula, and it's used to calculate the slope of the red line, and that red line is called the tangent line. So now, the tangent line is a linear line, linear straight, right?
Yeah.
So the tangent line is a linear straight line which kisses the function at f of a, and it is perpendicular to the curvature. Now, this calls for explanation, so let's draw some function f of x in xy plane, and then draw a tangent line at f of a. First of all, the term kisses.
It's a 1 point, yes?
1 point, exactly.
One no less than.
Right? Cannot be more than that. Tangent line, it says, because I can stretch another line between 2 points. It's not a tangent line. It has 2 points of contact. So tangent line is exactly 1 point. Now, perpendicular to curvature. Anytime when you have any type of a curve, you are able to fit a circle for the curvature you have. Yeah, that circle doesn't apply on the sides, but it applies in a small neighborhood perfectly, a small neighborhood around the point of interest, which is where they touch. And that circle will have a radius to its center, and the tangent line is always perpendicular to the radius of that circle. So the steps are very easy. We have some kind of curvature. You pick a little bit to the left, a little bit to the right, and you fit the perfect circle of whatever size it needs to be. If there is a sharp turn, the circle is smaller. If it's a mild turn, the circle will be very large. And whatever you draw this, so now the point of contact between the function and the tangent line will be on the circle now. If you stretch the radius from the point to the center, the tangent line is always perpendicular to that radius. So that's what it means, it's perpendicular. So tangent line is defined through this. But we know that we can calculate the tangent line by using the formula above. So m tangent is equal to limit h goes to 0 of f of x plus a plus h minus f of a divided by h. To compute the slope. So let's say we have a problem. Find the slope of the tangent line, so m tangent, at, let's say x equals to 3, given f of x equals x squared minus 3x plus 1. Well, first off, these 3 is our a, because you are looking for the slope at x equals a. So our 3 is a. Then we have, so slope of the tangent line will be limit h goes to 0. And now I need my f of a plus h, which is actually a is 3, minus f of 3 divided by h. So how much is f of 3? It's going to be 3 squared minus 3 times 3 minus 1, all together negative 1. And how much is f of 3 plus h? It's going to be 3 plus h squared minus 3 times 3 plus h, minus 1. And we have to expand this, so that's going to be 9 plus 6h plus h squared minus 9 minus 3h minus 1. So that's a 9, 6h plus h squared minus 9 minus 3h minus 1. So now 9's cancel. We have h squared plus 3h minus 1. We have all of the ingredients, so now we plug everything in. F of 3 plus h is h squared plus 3h minus 1. Minus f of 3 is negative 1 divided by h. Well, now these 1's cancel. And we see that we can... Oh, I forgot the limit. Holy nightmare. That's minus 1 for me. Each limit you drop in a problem is minus 1. So I just lost the point.
Oh.
So now we factor out h plus 3 divided by h. So now the h cancels. And we finally have that m tangent is equal to 3. So slope is 3. If I change the point A, would the slope change? If I change location?
No.
If I move the point, let's say here,
Oh.
now the slope is different, right? So if I change the value for x, the slope changes. So same problem, different slope. F of x equals x squared minus 3x minus 1.
I don't think I understood that.
And let's say x equals to, I don't know, 7, whatever. So go through the whole procedure again for x equals 7. So now your a is 7, right? Plug into the limit formula and get the slope. What happened? Air. Like this? All right.
Thank you.
You are welcome.
Let's get rid of the negative 1 in that equation again.
What do you mean get rid of? I canceled it. Negative 1 minus negative 1 is 0.
Yeah, of course. Add it without, and it would change the balance of the equation, correct? Okay.
All right, so now we have f of 7 to worry about, which is 49 minus 21 minus 1. That's 28, 27. And then we have f of 7 plus age, which is 7 plus age squared, minus 3 times 7 plus age, minus 1. That's 49 plus 14 age plus age squared minus 21 minus 3 age minus 1. 41, so 49 minus 21 minus 1, that's going to be 27 plus 11 age plus age squared. So now, to calculate m tangent, we go limit, age goes to 0, and now instead of f of, well, let me write it, f of 7 plus x minus f of 7 plus age divided by age, and we just plug in. Limit, age goes to 0. We have 27 plus 11 age plus age squared minus the f of 7 was 27 divided by age. 27s now cancel. And we factor out age to cancel in denominator. We have 11 plus age in parentheses. Now age dies. And when age goes to 0, we just get 11. So M tangent is 11 this time around. So when we change the point, the value of the slope changes. So now, I just realized that I actually didn't want a 7, I wanted -5. So it's the same problem, but now x is -5. And then right when you are done with that, I will immediately give up on -5 and ask about 2/3. And then when you're done with 2/3, I'll say, well, wait, what's happening if x is 1,000,000? And then when you're done with that, I want to know what happens when x is -2,000,000. And then when you're done with that, you see the problem, right? I can think of infinitely many numbers. You have to repeat the whole procedure from scratch every time we change the location of the point. That's exactly what we are aiming at. Instead of calculating each one of these points individually, how about we calculate for all of them and then just plug in the values that we need. You see, this now will ask us to repeat the whole procedure. Nah, lazy. So what are we going to do instead? Instead, we are going to change our formula. Don't write this yet. M tangent that we had, don't write this yet, limit h goes to 0 of f of a plus h minus f of a divided by h. Well, this formula had a specific a in it, and every time I change the location, the a changes, and then I have to redo the whole problem. How about if I swap this a with x? Because x stands for all the values in the domain. So all I have done is I changed those a's for x's. So now, yep, I'm going to calculate for all values of x rather than just one individual and then have to change them right? So restart. So, yep. So f of x is given as x squared minus 3x minus 1. That's good for our formula. We already have that. I need f of x plus h. So that's going to be x plus h squared minus 3 times x plus h minus 1. X squared plus 2xh plus h squared minus 3x minus 3h minus 1. So you expand the square, you multiply -3 in, and then you just copy -1. So now, to find all slopes that are possible, all we need to do is to calculate limit, no coughing, h goes to 0. And now, f of x plus h is going to be this long x squared plus 2xh plus h squared minus 3x minus 3h minus 1 minus x squared minus 3x minus 1 in parentheses, everything divided by h. So m tangent, which is the limit h goes to 0. Now, x squared and negative x squared cancel. Negative 3x and positive 3x cancel. And the negative 1 and a positive 1 cancel. Because when you distribute this negative sign, all the signs change. They all cancel. And what you are left with is 2xh plus h squared minus 3h over h. Note that all of the terms in the numerator have h, which you can factor out. So you factor out h, you get a 2x plus h minus 3 divided by h. This is where h cancels. And you finally have your, well, we can put it here, 2x minus 3 when h goes to 0. This h goes to 0 because h goes to 0. What you have right now is that the m tangent is equal to 2x minus 3. You did not get a particular slope. You got all of them. Now, you give me x, I'll give you slope like this. If your x is 3, what's your slope? 3. If your x is 7, what's your slope? 11.
Oh.
And those are the ones that we calculated a long way, right? Remember how I said I would like to know about negative 5? Well, now that's easy. What's the slope? Negative 13. Remember I mentioned 2/3? What's the slope for 2/3? Not 2/3, sorry, 3/2. 3/2 is easier. 0. Slope is 0, right? Because when you plug in 3/2, 2 and a half cancel. 3 minus 3 is left. 3 minus 3 is 0. So what is this? This is now a function which generates all of the slopes. I'm going to write that one in blood over here. Wow. That's cool. What's the name of that function? Slope generator? No? Is there a shorter name for that function?
Derivative.
The derivative. What is the derivative? The derivative is the function which generates all of the slopes for all of the tangent lines you can possibly have on a line. Oh, and it measures the change. What is the derivative? The derivative is a function which you can use to calculate all of the slopes, all possible slopes for a given function. So, this is called the derivative. The notation for the derivative is f prime of x, and it's calculated by the limit h goes to 0, f of x plus h minus f of x divided by h.
Is that one more? Or why is there one
Where's 1?
above the f of x?
It's a prime.
Okay.
That's like a tick. There will be second derivative, third derivative. It's the order of the derivative, and this is the first derivative, so we just call it the derivative. And the notation is f prime. There are other notations as well. We'll deal with that later. What's the derivative? Derivative is a function which calculates all of the slopes for a given function. Great. So now, let's go and calculate, find the derivative of f of x equals 5 over x, and use it to find slopes at x equals -3, 1, 6, and let's say 2/3. You had this problem for homework in terms of a limit. All you need to do now is to get that answer again, and then plug each one of these values one at a time to calculate associated slopes. as you're calculating this, which trick do you have to use to solve the limit? Common denominator, very good.
Should we do the correct way to cancel out five over x's?
You have to combine them. You'll have double fraction. It's the same like the one that you had for the homework last week.
I don't think I did that. Solving for a common denominator, you said to add the fractions together.
Yep. All right, so f of x is 5 over x. F of x plus h is 5 over x plus h. H minus 5 over x. Everything divided by h. Common denominator, because the only thing we can do here is to find common denominator and combine fractions. So common denominator is x plus h. In the numerator we'll have, when we cross multiply, 5x minus 5x minus 5h. Everything divided by h you can put over 1 if you want. 5x's drop. So now I'll catch you up later. Negative 5h over x plus h. Oh, x is an h there, this h. And now h has dropped. So all we have to worry about is this, where h goes to 0. And we have negative 5 over x squared. So now, if x is negative 3, corresponding slope is negative 5 over 9. Great. If x is equal to 1, slope is negative 5. If x is 6, slope is
36.
great. And if x is 2/3, how much? Negative 45/4. Good now. When you compute the derivative, you have a function that can generate all of the slopes of the tangent line. I mean, all the slopes for all tangent lines that you can possibly have. Now you tell me which x value is forbidden. 0. Do you see that the 0 doesn't work in a function? 0 doesn't work in a derivative either. Our function is 5 over x. So 0 would make it 5 over 0. Well, that's no bueno. And our derivative is negative 5 over x squared. Well, that would make it negative 5 over 0 again. So the, quotes, bad value for a function is also at the same time bad value for the derivative. So we are only looking into the values that are in the domain, which is why domain exercises were important in our chapter 1 review, right? So that you don't bother with the derivatives of the values that actually don't exist. So let's recap this. Going all the way back to the slope of the line, you need 2 points to define a line. Call them A and B, P and Q, I don't care. And then, if you involve a function, the point Q will go closer to point P, and that motion is where the calculus is born, right? Study of motion, study of change. And we derived by replacing static y's with f of x, right? The formula that will calculate the slope of the line given 1 point. Now, if that's not making you excited, you're in the wrong class. Because for years, people have been telling you that you have to have 2 points to find the slope of the line, right? For years. And now I told you, you can use 1 point to find the slope of the line. Still nothing? You're terrible. Wow. All right. So we found the formula to calculate each slope individually, but because we're all terribly lazy, and there you go, we swapped those a's for x's to find the formula. Which will calculate all of the slopes, and then we can calculate one by one. Now, since we have a slope and we have a point at which that slope is what it is, we can use those two pieces of information to find the equation of the tangent line, which is the natural extension of this problem. So, let me write that in blood. To find the equation of tangent line, we use the slope and the point in y equal mx plus b, or y minus y1 equals to mx minus x1, depending on which one you like better. I don't care. So what do we have? We have these specs. F of x is given as 5 over x. X was given as 1, and slope m was negative 5. That was given to us as one of the calculations, one of the options. So now we are asking ourselves, what is the equation of the tangent line? Well, I can calculate y value as f of 1, which is 5 over 1, which is 5. And now I have 1, 5 as a point, and m equals negative 5. I'll do problem both ways. So we can use y equal mx plus b. Y is 5. Slope m is negative 5. X is 1. Plus b, no coughing. And then we have 5 equals negative 5 plus b. B equals 10. So y equal negative 5x plus 10. Or y minus y1, which is 5, equals to negative 5x minus x1, which is 1. You can use the other formula, plug everything in it. Well, let me put the formula first, and then. So y minus 5 is equal to negative 5x minus 1. So y minus 5 is equal to negative 5 plus 5. No, negative 5x. And then add 5 to both sides. Y equals negative 5x plus 10. So whatever method you like better, the goal is to calculate the tangent line so whichever method you like better. Now, the greatest thing about learning calculus at this age is that you can check your answers easily using the graphing tools. If you graph 5 over x and you graph negative 5x plus 10, you see that they meet at 1, 5.
And the y is, they're supposed to be examples still, but b still one answer.
B is the y-intercept for the tangent line, and you can see that I zoomed in now so you guys can see all of the features. So let's take a look at this graph. You can check every problem on decimal. You graph your original function given to you. It gives you the color. That's going to be the red line. We all know what the 1 over x looks like, right? The blue line is the tangent line you got. And then you see all of the features. Your b equals 10. That's the y-intercept. The blue line does cut through the y-axis at 10. And you see that the two functions, as the definition said, kiss at 1, 5. So that's the point at which you asked what is the tangent line at 1, which is why the whole problem is centered there. That's the point where the tangent line and the function touch. So if you graph both of these, they always have to meet at the point where you look for the tangent line. So now you can go and you can take a look at the other value. Obviously, the tangent line will change its location. The tangent line formula will be different. And you can calculate this. So we will be calculating tangent line in every section of chapter 3. Every section of chapter 3. And it will be featured in at least 3 or 4 problems for the remaining exams. Exams 2, 3, and the final will all have tangent lines, as tangent line is one of the main focus points of Calculus 1. Tangent line measures the change, because tangent line is a slope line that shows the change in value over time. In this particular case, the value is diminishing. Well, we see that the blue line has a negative slope, which means that the value of the red line, this is the content of the next lecture, meaning that the red line is losing on value, and you can see that the red line is decreasing. So a lot of good stuff about functions will be revealed to us through the slope of the tangent line, which is why the tangent line is the line that measures everything, and the reason why the tangent line is the main focus of Calculus 1. So most of your stuff, obviously tangent line will be back in chapter 4, and then eventually it will become a tangent plane in Calculus 3, which is, I think I'm teaching that tomorrow in my Calc 3 class, the tangent plane. So make sure that you can find the equation of the tangent line. Make sure you can do the derivative by taking that limit, and everything will be good. Now let's take a look at another example from homework. And then take a break. Here's a wonderful problem. Try to work on this one. You guys also have people sitting around you, so you can try and talk. They might be interesting. You don't know. until you try. So square root of 2x plus 1. And they're looking at the point x equals 4. It's problem 39 in the textbook. So 4 is your a value, right? That you will be using in your calculations. So let's go. You find the derivative through the limit, plug in 4 to get the slope, figure out the values.
Well, yeah, we'll actually go.
Okay, let's take a look at this together. So f of x plus h is the square root of 2x plus 2h plus 1. When you replace x with x plus h and distribute 2. So now, limit h goes to 0 is square root of 2x plus 2h plus 1 minus square root of 2x plus 1 divided by h. What now? Excellent. Multiply by the conjugate, and that would be times square root of 2x plus 2h plus 1 plus square root of 2x plus 1. You have 2x plus 2h plus 1, 2x plus 1. So now we get 2x plus 2h plus 1 minus 2x. And usually this is where things go horribly wrong. Needs to be minus 1 because the negative distributes. Divided by h, square root of 2x plus 2h plus 1 plus square root of 2x plus 1. So it's messy, but doable. 2x, negative 2x, plus 1, negative 1, cancel. And then finally, we can cancel age and age. So limit age goes to 0. The only thing that stayed up there is 2. And in the denominator, we have a square root of 2x plus 2age plus 1 plus square root of 2x plus 1.
How the x be cancelled out again?
What happened?
How the x be cancelled out?
Positive 2x and negative 2x.
No, what I meant to say was the h at the bottom, in the denominator.
So when all of this canceled, the only thing that stays is 2age.
I see.
And then age and age cancel. That's why it's blue. You are welcome. So now, this goes to 0. And we are left with 2 divided by 2 square root of 2x plus 1. And now the 2's cancel. So 1 over 2x plus 1. So now I have that the slope is given by the formula 1 over 2x plus 1. They want the slope at 4. So for x equals to 4, we have that the slope, this is the derivative, f prime. M is equal to f prime computed at 4, which is 1 over square root of 2 times 4 plus 1, which is 1 over square root of 9, which is 1/3. You plug in the value. You plug in 4 into the formula. And now, to find the y, that's going to be original f of 4, which is square root of 2 times 4 plus 1, which is square root of 9, which is 3. And we have everything we need. Plug in to find b, and we're done.
Sorry, I lost track of this again.
Good. We're going to review the whole problem. So this is what's given to us. Function and the value at which we want to find the derivative. We need f of x plus h in order to compute the difference quotient and then eventually do the limit. So we create f of x plus h by replacing x with x plus h and distributing 2. And then we plug everything into the formula. That's f of x plus h minus f of x divided by h. Now, since we have a difference of 2 square roots, we can do the conjugate, multiply by the conjugate. And when we multiply the numerator, we have difference of squares. So that will just eliminate square roots and keep the minus in between. Usually grade dies with this sign over here, so be careful. And then when everything cancels, the red cancellations are happening first. The only term that stays in the numerator is 2h, and then h cancels with the h in the denominator, which is blue cancellation. That's the second wave of canceling. And finally, we have this step where we do not have a 0 in denominator, so now we are allowed to plug in age equal to 0. When I plug in age equal to 0, we get square root of 2x plus 1 plus square root of 2x plus 1. That's 2 square roots of 2x plus 1. And in that case, the 2's will cancel, leaving the derivative as the answer in the end. Now, that derivative can be used to calculate any tangent line given whatever point, right, we need. Well, they wanted to calculate tangent line, or the slope first, at 4. So we will plug 4 into the derivative to calculate the slope. So that's happening here. Slope is equal to f prime of 4. F prime is the derivative. When you compute derivative at the point, you get the slope. So we got that m is equal to 1/3. And we also need a y value, because we need to plug in y equal mx plus b, so I have to calculate y as well, which is happening here. So y is f of 4. That's where we calculate the function value. So that's a standard pre-calculus calculation. That worked out to be 3. And finally, I have my standard algebra problem to find equation of the line with the slope and the point given. You can use either y equal mx plus b, or you can use point slope formula. Y minus y1 equals m times x minus x1, whatever you like better. And once you plug in y, m, and x, which are all given to you there, you get b is 5/3. You plug in your m, you plug in your b, and you have your y equal mx plus b equation of the tangent line. You'll be sick of this calculation by the end of the next, 3 weeks of the class. We'll pretty much see this every day or every other day, depending on how often do we have to calculate this. In chapter 4, this will be recasted into something that we call linearization. And then in Calculus 2, you will improve on that even more. Calc 3 becomes a tangent plane, so on. So this is one of those things that as you keep going with math, it never goes away. So it's the best if you learn it now very well, so that you don't have to relearn it every other time you see it again, and you will see it a lot. So let's take a break, and then when we come back, we have another section which is kind of shorter and easier